Welcome to the Explainer. Let's just jump right in, shall we? Look, if you're tuning in today, you've probably run into what is literally the most universal frustration in all of gardening. You know the drill. You carefully map out your beds. You spend good money on seeds, water, and those supposedly premium, super expensive fertilizers, and yet your plants are still turning yellow, they're stunted, they're just not thriving. It's like you're doing everything right, putting in all the correct inputs, but the outputs are just incredibly disappointing.
And man, it drives us crazy, doesn't it? Like, why does your neighbor's garden look like this lush, vibrant jungle while yours is barely hanging on life support? Honestly, you're probably using the exact same seeds and the exact same municipal water, so what gives? Well, here is the cold, hard truth. The problem isn't your seeds. The problem is that the ground right beneath your feet, it might actually be completely dead.
But don't worry, because today we're going to fix that. Here's our quick roadmap for this explainer. First, we'll look at the garden cemetery problem. Then, dirt versus living soil. After that, we'll get into the 5-minute diagnostic test. And finally, reviving your soil ecosystem.
All right, starting right off with Section 1, the garden cemetery problem, or when plants merely survive.
You know, most gardeners, the second they see struggling plants, they instinctively run out to buy more of these so-called magic inputs. We're talking more synthetic fertilizers, more sprays, more pesticides, but doing that completely ignores the invisible root issue. If your soil is dead, your plants are basically just surviving. They are definitely not growing. The source material uses this incredibly vivid metaphor that I absolutely love. It says dumping fertilizer on dead earth is, quote, like trying to feed a steak to a newborn baby. Think about that. The nutrients might technically be sitting there in the soil, sure, but the entire biological system required to actually digest those nutrients and hand them over to the plant, it's just completely missing.
And that leads us nicely into Section 2, dirt versus living soil, a subterranean buffet.
Okay, so before we even think about testing our ground, we need to know what we're actually looking for, right? What does microscopic life in the ground look like, and what is it even doing down there for our plants? Well, try picturing a massive subterranean buffet that is open 24/7. The contrast here is literally night and day. Dirt is essentially a graveyard. It's just dead minerals. It might smell sour, or maybe it just smells like absolutely nothing at all, and it's usually either baked as hard as a sidewalk or as fine and lifeless as dust. But soil? Soil is a living, breathing biological engine. Get this, in a single teaspoon of healthy soil, there are more living organisms than there are people on planet Earth. That's wild, right? We're talking about a microscopic army of bacteria, fungi, protozoa, and nematodes. They basically act as your garden's personal chefs, constantly breaking down organic matter into food that your plants can actually eat, all while actively defending those roots from disease.
Which brings us to the really fun part, Section 3, the 5-minute diagnostic test, where we learn how to interrogate your ground.
Honestly, the best news you're going to hear today is that you do not need a PhD to figure out what kind of ground you're working with. And nope, you don't need some $500 lab kit either. Literally all you need is a shovel, 5 minutes, and your own physical senses. That's it. We're going to walk through 4 distinct physical phases of assessment here. Step 1 is the olfactory test. Step 2 is the structure test. Step 3 is the biodiversity audit. And step 4 is the infiltration test. Let's break down exactly what you're going to do when you step out in your garden today.
First things first, you've got to pull your soil sample from the right place. Don't just scrape that top inch of mulch off and call it a day. You actually need to dig down about 4 to 6 inches, so roughly 10 to 15 centimeters. This specific zone has a name. It's called the rhizosphere. And it is the immediate area right around the plant roots where all the biological magic actually goes down. So grab a big old handful of this earth, because that's what we're using for our first test.
All right, step 1, the olfactory test. Bring that handful of rhizosphere soil right up to your face and just take a really deep breath. You are actively smelling for a chemical called geosmin. It's that super rich, sweet, earthy aroma that you get when you walk through a forest right after a rainstorm. It's actually produced by a very specific type of soil bacteria called actinomyces. And here is a crazy fact. Humans actually evolved to be incredibly sensitive to this smell so our ancestors could sniff out fertile land and water. In fact, our noses can detect geosmin even better than sharks can detect blood in the water. How cool is that?
So the crucial thing here is how you actually grade this smell test. If it smells like a forest floor, amazing. You have a high, super healthy microbial population. It means your soil is breathing. But if it smells like absolutely nothing, like just wet dust, well, that's a pretty big red flag. It indicates very low microbial activity. But the absolute worst outcome? A sour, rotten egg or ammonia smell. If you smell that, it means you've got an anaerobic problem. Basically, your soil is probably so compacted that oxygen literally cannot get in, so all the good microbes have suffocated and the bad bacteria have totally taken over. And those guys produce alcohols and acids that will literally melt your plant's roots.
Okay, let's move on to step 2 and see how all this builds into the actual physical body of the soil. This is the structure test. For this one, you just want to give that handful of soil a really firm squeeze right in your palm. What we're testing for here is the presence of glomalin. Glomalin is basically this biological glue that gets secreted by fungi, and it weaves all the little soil particles together into a nice, stable, porous structure known as an aggregate.
So when you open your hand after giving it a good squeeze, one of 3 things is going to happen. First, if the soil holds its shape but then easily crumbles when you poke it, kind of like a perfectly baked chocolate chip cookie, you, my friend, have struck gold. That means those fungi are doing their job, creating perfect little pockets for air and water. Now, second scenario, if it just falls apart instantly, like dry sand or dust, you've got zero structure, no biological glue at all, which means all your expensive nutrients are just going to wash away the next time it rains. And the third scenario, what if it stays in a hard, sticky lump, kind of like a ball of Play-Doh? Well, that means you have severe compaction. Your plant roots are basically suffocating inside a solid brick of clay.
Moving on to step 3, the biodiversity audit. For this, go ahead and spread a nice shovelful of your soil onto a tarp, or even just a piece of cardboard, and gently sift through it to see exactly who is home. Now, the absolute gold standard here is the earthworm. They are the primary engineers of your soil. Believe it or not, if you find just 3 to 5 earthworms in a single shovelful, your soil is remarkably in the top 1% of health. Seriously. It means there's abundant food and a safe, chemical-free environment for them to just thrive in.
But hey, don't just look for the big guys like worms or beetles. You also want to look super closely for these thin, white, thread-like structures that honestly look a little bit like a spiderweb. This is called mycelium. It acts as the literal internet of your garden, connecting different plants, sharing nutrients back and forth, and protecting them from disease. If you're sifting through your sample and it's just eerily quiet, no worms, no bugs, none of those white fungal threads, then your soil is basically a ghost town. And that means your plants are completely dependent on you for every single drop of food, which, let's be real, is an incredibly exhausting way to garden.
All right, our final diagnostic, step 4, is the infiltration test. Look, soil life obviously needs water, but it also desperately needs to drain efficiently. So for this one, just find a flat area of your garden and pour about 8 to 10 ounces of water right onto the surface at a nice steady pace. What you are looking for here is what we call the sponge factor. See, really healthy soil acts exactly like a giant sponge because all those little worm tunnels and fungal pathways we just talked about, they create this massive built-in drainage system.
Here's exactly how to read those hydration results. If that water absorbs straight down in seconds, your soil is functioning as a perfect sponge, beautifully holding onto that moisture in its pores for later. On the flip side, if the water just sits there in a puddle on top for a minute or more, your ground is what we call hydrophobic. Basically, the skin of the earth is closed shut. That water is either just going to evaporate or run right off, and it's probably taking your precious topsoil with it. Alternatively, if the water disappears instantly, like you just poured it into a gravel driveway, it means you lack the organic matter needed to actually hold moisture. Your plants are going to be thirsty again in like 20 minutes.
And that brings us to our final section, reviving your soil ecosystem, which is really all about the paradigm shift.
Okay, so you've spent your 5 minutes and you've gathered your scorecard. If your soil smells like a forest, crumbles perfectly like a cookie, has worms wiggling around, and drinks water like a sponge, congratulations. You are the steward of a thriving ecosystem. Honestly, just get out of the way and let nature do its thing. But what if your results showed a barren, hard, completely empty ghost town? First off, take a breath. Do not panic. And whatever you do, please do not run out and buy more synthetic chemical fertilizers. I know we are so conditioned to just feed a struggling plant directly, but as the source material strictly warns, doing that is exactly like giving a double espresso to a starving person who hasn't eaten a real meal in a month. Sure, it gives them a momentary jolt of artificial energy, but it completely fails to solve the fact that they are fundamentally starving. And it gets worse. Those synthetic salts often end up killing off the very few beneficial microbes you actually have left in there.
Instead, here's what your actual next step should be. The analysis suggests viewing a dead result purely as a diagnostic. It really just means that the biological bridge between the minerals in the ground and your plant's roots is temporarily broken. You've got to rely on the fact that soil is just incredibly resilient. Even dirt that's been baked, tilled, and poisoned still retains this ancient, hardwired memory of how to be alive. Your silent biological partner is honestly just on strike, waiting for you to provide the right conditions to wake back up. To fix it, you have to completely shift your mindset. Stop treating your garden like a chemistry project and start treating it like a biological one. We're talking about adopting methods like heavy mulching, adding real organic matter, and inoculating the ground with good quality compost.
Ultimately, it requires adopting this really fantastic mindset shift. Think about this. You are no longer just a grower of vegetables, you are now a builder of soil. Once you focus your energy on building the soil will quite literally grow the vegetables for you. It totally changes gardening from this high-stress, constant maintenance job into this really beautiful, natural collaboration.
So, I'm going to leave you with this question to chew on as you go grab your shovel and head outside to do your own 5-minute test. Moving forward, will you continue treating your garden like an exhausting chemistry project, or will you start treating it like a thriving biology project? The choice is quite literally entirely beneath your feet. Thanks for joining me on this explainer, and hey, happy digging!